Hello and welcome to another video in the graph series. Without wasting any time, let's get to the question. This is the question that is given to us, number of islands. What is an island? We obviously have to find the number of islands, but what is an island? So we are given a binary grid. So it is basically made of ones and zeros. 1 is land and 0 is water. I know you must be thinking that how would I understand this is a graphs question? Right now you know because this is in graph series, but we will try to understand that how will we know that this is a graphs question or how to even approach this, right? We will understand the intuition. Right now, first let's understand what is the question. What is an island? Island is basically land that is surrounded by water. Island is surrounded by water, and how is it formed? By connecting adjacent lands horizontally or vertically. So connecting should be your first clue that okay, we have to connect. And what are we connecting? Different points in this matrix, right? And how are we connecting them? Only horizontally or vertically. So if you would have been in an interview, your question should have been, can we connect them diagonally as well? Like for example, here it is given that it should be connected only horizontally and vertically. So basically like this, like this, like this you can connect. But for example, there was a 1 over here, okay? In this place, suppose there was a 1. So we could have connected like this also, right? So you could have connected diagonally also. So this should be a question that you should be asking whenever you're dealing with matrices and whenever you're connecting any 2 points in the matrix, correct? That should we connect them horizontally, vertically only, or can we connect them diagonally also? You may assume all 4 edges of the grid are surrounded by water. Now this is a very, very important point. Again, if it is not given to you, you should be asking this question. Why? It is given that all 4 edges of the grid, so basically if this is the grid, all 4 sides there is water. How is that relevant for us? It is relevant because island is surrounded by water. Basically, if there was no water over here, if it was given that it is land all over the place, right? Then this is not island. Island is supposed to have water all the sides. So because it is given that there is water all the sides, even these ones together form an island. Okay, let's see that what are the number of islands for these examples. So in this example, the output is 1 because there is just one huge island. If you see it, these ones are connected, right, horizontally. Then this one and this one are connected vertically. Then this are also connected vertically. So these 6 you can see, like these 6, not this obviously, these 6 together form island and they are connected to this. Now these 2 are also vertically connected. So this entire thing is forming one huge island. Why it is island? Because there is water over here throughout the surroundings and there is water over here also. It is given in the question that all 4 sides of the grid is basically surrounded by water. Here how many islands are there? The output is 3. How is it 3? So if we see these 4 make one island, right? Because there is water, there is water, there is water. Versus over here, see this one, is it connecting to anything else? Vertically or horizontally is it connected? No, right? So this is another island. This is also another island because vertically or horizontally there are no other ones. So there are 3 islands. Think about it, that if you could have connected diagonally also, then how would have answer changed over here? Then these would have connected over the diagonal, right? Then there would have been one huge island instead of 3. So these little details are very important. And here, because you're forming a connection, like this is a matrix question, but you're forming a connection. So this is your first clue that graph questions can also have matrices, right? So this is one type. Even though it might look easy to you, especially when I tell you the intuition behind it, you might go like, "Haan, this is very easy." But writing code in matrix question, when you have to connect horizontally, vertically or diagonally, basically you should know how to write the code, okay? So you should have done at least one question of this type to be able to write this code. And if not, this is your question to do. And if you can do this question, you will be able to understand a lot of similar questions. Basically, whenever you have matrices and you have to connect some points horizontally, vertically, diagonally, you will understand a very good concept today. So please do not miss the video and watch it till end. Before we move ahead, I would just like to take a moment to remind you to be consistent and make sure you do not miss any videos in the graph series. So make sure you subscribe, hit the notification bell icon. You will also stay motivated and you have no idea how much your support will mean to me. There's so much of free content available on the channel. There's HLD, LLD, DSA, Advanced C++, tutorials, mock interviews, and so much more. So if you think I deserve your support, please subscribe, hit the notification bell icon, And there's obviously a bunch of stuff that I cannot do on YouTube, like mock interviews, live interactive classes. So we have educourses.com, we have live courses, self-paced courses with live doubt solving support, which both of them we have mock interviews, and we have a lot planned in LLD, HLD, Advanced C++, DSA, and so much more. You have no idea. So if you want me to be part of your further learning journey process, please check it out. The link is in the description. And now let's continue. Now let's try to build the intuition behind this. It is actually very similar to the number of provinces question that we have already done before. If you have not done it, I would highly recommend you to go watch that video as well. The intuition is exactly the same. This is a very, very similar question. You will see that it is literally the same concept. And now you should be able to relate these questions. The only thing is that the way the graph is formed is completely different. But the intuition, the question concept is exactly the same. So over here, if we have to calculate the number of highlands, how are we going to do that? Now think about it. If I start from any one land, okay, suppose I start from here, okay, and I start going to the points that are connected to it, basically to all the lands that are connected to it, in that traversal, I will be able to form one island, right? So if I start traversing from here, I'll end up traversing the entire island. Versus over here, if I start from here, I'll end up traversing this island. But now how do I traverse this island and this island, right? So for that, we would have to go through all the nodes and see, is this forming a new island or not? So basically, we obviously have to keep marking the nodes visited. And how many times would we have to traverse? That is the number of islands types. I'll explain it in detail. Don't worry if you're overwhelmed right now. Let me explain it. Now, first thing that you need to understand that here we can do either BFS or DFS to traverse. Most of the people just do DFS and they are like, it is easy to code and we are going to use DFS. And most people just assume that this cannot be done using BFS. Now that is completely wrong. Please don't do this mistake. We just have to traverse, right? You need to understand the basics clear. You need to understand this and you need to be used to writing both code, BFS as well as DFS. So over here, if I start traversing, I can traverse through BFS or DFS. My goal is to cover all the land that is there in that particular island. So in one traversal, I will cover all the nodes that are there in that particular island, correct? So when I traverse this, I will keep marking them as visited. So basically, if I start, suppose from here, I will mark all of these as visited. So I obviously don't need to traverse from any of these nodes again, right? Similarly, I will keep checking for all the nodes that if this is not visited, that means this is potentially leading to a new island. So let's start writing the code. I'm sure it will be completely clear. We will be writing the code in both C++, Java and both BFS and DFS, and I highly recommend that you should also try writing the code in both BFS, DFS. Don't just watch the videos, but try writing the code yourself and in both the solutions. And the solution, all the 4 solutions, C++, Java, BFS, DFS, everything is present on Educourses under the free content section. You can see the code is present, so you can refer that as well. Please do check it out. Now that you understand the intuition behind the question, it is also important to understand that how are you going to traverse here through the grid, right? Because now we know that the nodes are connected horizontally and vertically. So let's talk about how would you write that in the code, right? So suppose this is the grid. Now you are at any particular element. Suppose you're over here. Now you know that the nodes that are connected to it, basically the adjacent nodes or the neighbors are which ones? The exact top one, the bottom one, the right one, the left one. Obviously, we will have to check whether they are also ones or not. Now that is another story. But how do I go to top, down, right, left, right? From every element, I would have to do this. So for this, there is a very nice way of writing code and just listen to it very carefully. Once you understand it, you go like, oh, this is such a beautiful way of writing code. If you have not seen it before, this would be like, oh my God moment. If you have seen it, you would understand it very easily, right? So here, suppose this node is at the point I, j, okay? So what will be the rows and columns, or if I have to make it easier for you, suppose this point is at r, c. So r is the row, c is the column. So what will be the location of all the 4 adjacent elements? So this will be where it is at the same row, but the column is +1, right? So r and c +1. This is where, again, row is same, it is at c -1. This is where it is in the row above. So r -1, but the column is same. And this is where this is basically r +1 and column is same, correct? So for any point r, c, who are the 4 points that we have to go to? Basically r -1, c and r +1, c, RC minus 1 and RC plus 1. Now I can go through them in any order. It is not like first I have to visit this, then I have to visit that, right? I just need to visit all of them somehow and I need to check all of them. So at any point R comma C, what are the points that we are adding? Basically, if I have R comma C, in R comma C, what are the values that I am adding? If you see over here, in R comma C, I am adding minus 1 comma 0. Here I am adding plus 1 comma 0. Here I am adding 0 comma minus 1. Here I am adding 0 comma plus 1. So if you think that whatever value that I have in my R comma C, if I just add these 4 values, I will have the neighbors, correct? And there will always be 4 neighbors only, because I have to go where? I have to go to top, bottom, right and left. So basically to go to the neighbors, I just have to add these 4 values like in R comma C, and I will be able to go through the neighbors, right? Similarly, think about it. If we could have gone to say diagonally also, what would have been the values? The values, now there are 4 more values, right? Total would have been 8 values. So this would have been what? This would have been 1 row above, so R minus 1, C plus 1. This would have been what? This would have been R plus 1 and C plus 1. This would have been what? R plus 1, C minus 1. This would have been what? R minus 1, C minus 1. So these 4 values, minus 1 comma minus 1, minus 1 comma plus 1, plus 1 comma minus 1, plus 1 comma plus 1, these 4 values could have added, and then there would have been 8 neighbors. This is simpler question. There are 4 neighbors. But if you want to do a follow-up question, a very simple thing is just add 4 more neighbors for every single node. So this was the interesting point in matrix related questions when it comes to graph, that how do you traverse? Now, if it is still not clear, it is fine. In the code, it will be much clearer. So now let's get started with the code. So I'm given a grid. First thing I need to find the number of rows and columns. It is given m by n, so I'm going to use the same variables. M is basically grid ka size, which is number of rows. Then I'm going to find n, which is my number of columns, so grid of 0 ka size. So this is n by m. Now, because I am forming a graph, why am I forming a graph? So each element in this particular matrix is a node in the graph, correct? So I need to mark them as visited. So how is my visited array going to look like? It is going to be a 2D matrix of the size m by n only. So I'm going to create that vector of. Now because it is just visited, true or false, I can keep it boolean. I could have also kept it integer. I'm calling it visited and of the size m by n. So initially everything is 0. So yes, I am going through all the elements in the grid, but when will I do the DFS? Firstly, it should be a land, right? So basically my grid of ij should be a land. And when will it be a land? When it is equal to 1. It is a character, guys, so I have to check 1. It is not integer, so keep these little things in mind. So firstly, if it is land and if it is not visited, maybe that it was already visited in the previous traversal. Maybe I started, suppose I am at this element right now. Now this would have already been visited from here. So I do not need to start another traversal because it is already visited, right? So only if it is not visited. So if I and j is not visited, only then what am I going to do? I am going to initially do DFS. And what all things do I need to pass? The grid, the visited, and ij, nm. That's it. Now what do I need to return? I need to return the integer, basically my number of islands. How can I find that? So I can initialize the counter, the res, whatever you want to call it. I'm initializing it to 0. And every time I do a new DFS, that means I'm encountering a new island, correct? So what will I do? Res plus plus. It is only when I need to start a new traversal, I need to increase my number of islands. So here I can just return the res. So now let's just write the DFS code. Coming to the DFS code, first thing, do we need to return anything? No, right? Because we just need to mark the nodes visited. So return type is void itself, DFS. What do I need to pass? I first need to pass the grid, so which is given to us. Again in C++, pass everything by reference. After the grid, I need to pass this visited to the array. Again, pass it by reference. Note these small things. And what else? I just need to pass ijmn, right? So ijm and n. So now this ij represents my current node. Okay, so grid of ij is my current node. What am I going to do? First thing that I need to do is mark it as visited. So visited of ij is true. I am at the current is now marked as visited. What am I going to do? Now I need to go through the 4 neighbors. How do I go through the neighbors? I need to form that 2D array that I talked about, right? It is not that this is the only way of writing the code. You could just call the function 4 times. You could just say that, you know what, Keerti, I'm just going to pass I plus 1j, I minus 1j, ij plus 1, ij minus 1, and I'm going to do 4 DFS calls. Now that is also absolutely fine, but this is how most of the people write code, plus this is extendable, right? I told you, you will be able to call for diagonals as well. Very easily extendable. Instead of 4 calls, you can just write one for loop. So this is why I would recommend you to, try writing the code like this. It is actually good. I'm calling it directions. You can call it literally anything. So this is a 2D array, and what will be the values? So if I am at the same row, it is going to be 0, minus 1 column, and 0 plus 1 column, right? Then if I have to keep the column same, then minus 1 row and same column, or plus 1 row and same column. So these are the 4 directions in which I have to go. Now in order to go through these 4 neighbors, what will I do? I will write a simple for loop. So if k equal to 0, till where it will be, there are just 4 elements, so from 0 to 4. Basically I want to go through these 4 elements, right? And what will I do? I just need the new I and the new j value, right? You can call it new r, new c. I could have called it as rc, and whatever you want to call it. New I will become what? I plus directions of k and 0. So basically what am I doing? So 1 by 1, so this is my basically directions of 0, directions of 1, directions of 2, directions of 3. So in directions of k, so basically if this is the element, the 0th one I am adding to the row, and the first one I am going to add to the column, correct? So new j is going to become whatever the value is there plus directions of k1. If it is still not clear, just try dry running that if ij value is this, and if I go through this for loop, what will be the new I, new j value? Just try dry running in and note down the new I, new j values. It will be completely clear. You are just trying to go in the 4 directions. Now I have found the new I, new j. Those are the 4 possible directions. But should I do another traversal from there or not? Now what are the 2 conditions? Firstly, that should be a grid, correct? So this like this, and it should not be visited. It is literally the same check, right? Firstly, it should be land, right? Only then I need to check. Otherwise, so it is not connected only. So here I am checking if it is connected. Basically, if it is land, only then it is connected. Then I am checking if it is not already visited, right? I obviously need to check if it is visited or not. If that is the case, what am I going to do? I am going to call DFS again. And what is my new current now? My new j, new I, new j becomes my new current. So what am I going to do? I am going to call DFS again, grid visited. Now my new current becomes new I and new j, and same m and n I am going to pass that. So now this is where the edge case comes up. What is the edge case? The edge case is that suppose if I am at this column or at this row or at this column or at this row. So suppose I am over here. If I do column plus 1, that is going to be out of bounds, and I am checking the grid value for that and visited value for that. So I am checking the values for which it is out of bounds. Similarly over here, if I do minus 1, it is going to be out of bounds, right? So I need to check that new I, new j is out of bounds. So a very simple way of doing that is that I will write another function and I'll just call it is safe. So this is a very common way of dealing with these things. So basically what I'm going to do is that I'm going to check, I'm going to call this function and I'm going to check that whatever new I, new j value that I have, is it within the bounds of m and n? That's all that I need to check. So if it is in the bounds, then only I will check that okay, grid value is 1, and if it is not visited. So 3 checks have to be done. First I need to check that this new I, new j is actually valid, because if you think about this, from here there are only 3 traversals possible. There is no traversal on top. Similarly from here there are 3 traversals possible. But from here there are only 2 traversals possible, right? So you need to check that it is safe to go to the new I, new j. It is actually safe to check the grid and the visited value. So these little nitty-gritty is very, very important. That is why you have to practice writing the code yourself. So what do I do? New I, new j, m and n, right? So how do I check? Basically it is literally a 1-line code that my new I, new j should be within the bounds. So my new I should be greater than or equal to 0, and new I should be less than m, and new j should be greater than or equal to 0, and new j should be less than n. So if this is the case, then it is safe to go to that value, and it is safe to check the grid and the visited value. If this returns false, if any of these condition returns false, that is why I am doing what? I am doing and, that all of these conditions should be true, then it is safe, otherwise it is not safe. just putting brackets for further clarity. So this is literally a one-line function. Let's try running it and see if this works or not. So yeah, this works. Let's submit it and see. Yes, we have passed all the test cases. What is the time in the space complexity? It is order of nm because we are going through all the nodes only once. Now we are using extra space for visited also, but if it is allowed, so you can ask or interview this, or you can talk about this, that if it is allowed to change the value of this grid itself. So maybe I can mark visited in this itself instead of needing a new completely array, right? So you can just keep marking, suppose instead of 1 or 0, I can mark it as 2. That means it was visited, right? So I can change state like this. So I could have avoided extra 2D array for visited. Now we are done with the DFS code. Let's see how much we would have to change to write the BFS code. So let's get into it now. So here we are doing DFS, right? Instead of this, we just have to do BFS. What do we do in BFS? We create a queue. But now what is a node over here? It is not a single integer or a single node that is given to us, right? Here every element in the matrix is a node. And how is that represented? By two values, R and C or I and J. So in the queue also I need to add two values. So basically I am taking a pair of integers. Now every pair will be the element. Basically every pair represents the node, right? R comma C or I comma J. So this is the queue. And from where am I going to start? So inside this for loop only, right? So where will I start? I will start at I comma J. So I am pushing I comma J, and I would have gotten into this only if it was land and only if it was not visited. After pushing I comma j, what do I need to do? I need to write a while loop that while my queue is not empty, what will I keep doing? I will keep taking out the frontmost node. I will keep going through its neighbors. So how do I take out the frontmost node? I can basically have two values, current I and current j. What will be my current I? In my queue ka front. So now there are two values, I comma j. Whatever is the first value, that is current I, and what is current j? It is going to be queue ka front, and whatever is the second value, that is going to be current j. Now that I have current I and current j, what do I need to do? I need to pop out this first element because now I have it in my current I, current j, right? Now I have my current node. What do I need to do? I need to go through its neighbors. I can literally just copy paste this entire code. So let's try doing that. If I take this, I need to go through the neighbors, and how am I doing that? So going through this 2D array, my new I will become my current I plus direction of K0, and new j will become current j plus direction of K1. And what do I need to check? Same thing, right? If it is safe, if the grid is land, and if it is not visited, but just instead of calling the DFS, I will again push to the queue. And what will I push? I will push new I and new j. That's it. Instead of calling the DFS function again, I just need to push it to the queue. Another thing that I need to do is mark it as visited. I am checking that if it is visited or not. I just need to mark them as visited as well. So here I am going to mark new I, new j as visited. And similarly over here also, when I call for I comma j, I am going to mark ij as visited. So that is the node from where I am starting the traversals, and all the other nodes as well, I am marking them as visited. And that's it. We are actually done with the code. This is it. Oh, I have missed an I over here, new I. And now let's try running it and see if this works or not. So this works, and let's try submitting it as well. By the way, the time and the space complexity for both BFS and DFS is completely same, right? Because we are visiting all the nodes exactly once. We have passed all the test cases. Very good. Please be consistent. Please keep showing up, and please do comment that you have understood it. Please try writing the code yourself. And if you think I deserve it, please do share the videos with your friends. Please do hit the subscribe button, notification button. You have no idea how much it will mean to me. Please help me reach more people. And now let's move on to Java code. We are given this grid. First thing that I need to do is find the size of it. So we are given m by n. I'm going to use the same variables. M is basically number of rows, so grid.length, and n is basically number of columns, so basically grid of 0 ka length. So now I have m and n values. Now because we are dealing with graphs, we need to have a visited array. Now what am I marking as visited? Each element in this grid is basically a node, correct? So what will be the size of the visited array? It would be m by n. So I can make it as boolean, and I can write it as visited, new boolean, m by n. Now note that I could have actually saved this space. I could have saved m by n space by not creating this. How? I could have marked it in the grid itself, that if it is visited, I could have marked it from say 1 to 2. Now this is something that you can ask your interviewer, that can I do that, can I save up on space like this or not? But not always you can do this, so I am just writing the code like this so that you get an idea. But you can make the change in the same grid also if it is allowed, and you could save up this space. By default, the initial values of the entire array is going to be false. Now what do I need to do? I need to go through the entire grid and I need to see that do I need to start a new traversal from here or not, right? So I equal to 0, I less than m, I plus plus. Now I need to check that do I need to start another traversal from this I comma j or not. Now what are the conditions? Firstly, this obviously should be land, only then, right? So how can I check that? That if grid of ij is basically land. How do I check land? That if it is one character. Notice that we are given character, not integers. Okay, so you have to check like this. So if it is land and if it is not visited, why do I need to explicitly check this? Suppose I am over here. Now this could already have been visited from over here, correct, from the previous values. So I do not need to start another traversal. When will I start another traversal? When I am across a land that has not been visited, right? So I will start new traversal at that time. And how am I going to do the traversal? Initially, I'm writing DFS code. So I need to pass the grid, the visited array, I, j, and nm, right? And every time I do this new traversal, that means I have come across a new island. So what will I do? I need to return this integer, right? So I can just create another, I can call it counter, I can call it literally anything. So when I do this, I am going to increment my res value or my counter value. Every time I need to start a new traversal, I need to increment the value. And in the end, I am going to return it. Now we just need to write the DFS code. Coming to the DFS function, do I need to return anything? No, right? Because I just need to mark them as visited. So I am just going to have the return type as void DFS. I am passing this grid. So I am just copy pasting the same as it is. Similarly, I need to pass the visited to the array. Then I, j, and m. Now another thing to note over here is that grid of ij is basically my current node, right? So when I am at my current node, I also need to mark it as visited. So I am marking ij as visited, correct? Now what do I need to do? I need to go through its neighbors. How do I go through the neighbors? As we had discussed, I need to go in the 4 directions. So for that, just stay with me. I am creating this 2D array. I am calling it directions. You could call it literally anything. And how is it going to look like? So there are going to be 4 elements, and in each of the elements, so basically if I have to keep the row same, then I can go to column -1. Similarly, if I have to keep the row same, I can go to +1 column. And similarly, I can keep the column same. So basically row, I can go to either -1 and column is same, or I can go to +1 row and then column is same. So these are the 4 values that I can add. And how will I go through these 4 values? So basically there are 4 values in this directions 2D array, right? So k equal to 0, k less than 4, k plus plus. Now note that it is not like you couldn't have just written 4 DFS calls. You could have. But this is a better way of writing. Why? Because this is also extendable. So if I ask you that tomorrow I want to include diagonal elements also, you would just have to make change in this and change from k equal to 0 to k less than 8 instead of writing 4 more DFS calls. So this is a better way of writing code, and just wanted to, write like this so that you get used to writing code like this. So instead of this, if you want to do 4 DFS calls, you can do that as well. You would have to pass I, j minus 1, I, j plus 1, I minus 1, j, or I plus 1, j. It will be like that. Now what am I going to do? I need to find my new I and new j values. So my new I is going to become the current I, and directions of k is going to give me 2 values, right? In that, the 0th value is the one that I need to add it in the row, and new j is what? In the present j, whatever j I have, in directions of k, I am adding the first one. So see, directions of k is going to give me like this. So this is directions of 0, this is directions of 1, this is directions of 2, and this is directions of 3. Now within that, this is for row, this is for column. It is like that. So now that I have value of new I, new j, what do I need to do? I need to see if I need to visit this or not, right? So again, this is this exact same check that is going to be there. But now the check is going to be for new I, new j. First, obviously, I need to make sure that it is a land, only then it is connected, right? So if new I, new j is land, and if it is not visited, if it is already visited, then I do not need to obviously traverse from there because I've already done it before, right? So if it is not visited and if it is land, what am I going to do? I'm going to call DFS again, but now my current element is going to become what? It is going to be new I, new j, m and n, and that's it. We are actually done. Not quite yet. So there's one important thing that you should be thinking about it yourself. So suppose I'm over here right now, okay, and I do row -1. So basically I'm going out of bounds. I'm going to a negative number. Similarly over here, there's nothing on top, there's nothing on left. There are only two values. Over here, there's nothing on right. So I am going out of bounds either to negative or to mn values, right? So I need to check that whatever this new I, new j is there, that is within bounds or not, right? So for that, because if I don't do that, then I'm trying to access the value at grid and at visited at new I, new j, which is out of bounds. I'm going to obviously have an error, right? So what am I going to do? I'm going to write another simple one-liner function where I'm going to check that this new I, new j is within the bounds of this mn. That's it. A very simple one-line function. That's it. And it is just going to return what? It is going to return me true or false. That is it safe or not to go to that new value. So what all things have I passed? New I, new j, I could also call it just ij, it is fine, call it anything, and mn, right? Now inside this, what do I need to do? I just need to return that the check should be that new I should be greater than or equal to 0 and it should be less than m. Similarly, new j should be greater than or equal to 0 and it should be less than n. That is it. All of these conditions should be true. That is, it should be within the bounds of this grid. Only then it is safe to go over there and only then I'm going to check the values. And that's it. We are actually done writing the code. So this runs. Let's try submitting it also. And also what will be the time and the space complexity? You are visiting all the elements of the matrix exactly once. So the time and the space complexity is order of mn. But here you could have saved on the space complexity. How? By not creating this visited, and you could have reused this grid itself. Coming to the BFS code, let's see how much code we would have to change. Obviously the time and the space complexity is going to remain same. But now instead of DFS, we have to do BFS, right? So what do we need for BFS? We need a queue. But now the question is that queue will be of what? Because usually it is of, like in the previous question we had of an integer, because the integer represented a node. Over here, what represents a node? It is set of two values, basically I, j or r, c, right? So what I am going to do is probably create a new pair. Now there are various ways of dealing with it. How I am doing is I am creating a new class and I am calling it pair. So inside this itself, I am calling it pair and I have two values inside this, the first and the second. So the first will be the row and the second will be the column. And there's going to be one simple constructor passing I and j. So int first and int second. So this ka first is going to be the first that is passed and this ka second is going to be the second that is passed. And now this queue of pair, let's finish writing this. In this queue, how am I going to start it? I'm going to start with pushing I and j, right? And how many times am I going to keep adding to the queue? How many times am I going to do the BFS? The number of islands times, right? But that is my res value that I'm going to get in the end. So how do I need to start this? I'm going to initially push what? I'm going to push a new pair. And what are my values? My values are I and j. And I am also going to mark it as visited. So I am marking I and j as visited. Now what am I going to do? I am going to keep going through the queue till it is not empty. And I need to go through the neighbors of the front element. How do I get the front element now? So the front element is going to be a pair. And how can I get it? I can just remove it. And now there are two values inside this current, right? So current I is going to be current ka first. And current j is going to be current ka second. Now I have current I and current j. Now what do I need to do? I need to go through its neighbors. And how can I do that? I basically just copy paste this entire code. So I pick this up, I copy it and I can actually remove the DFS code. I won't be needing it anymore. And over here I'm just copying it. Basically I'm trying to traverse through what? Through the neighbors of current I and current j. And how do I get that? So in this ij, basically current I, current j, I'm going through the same directions wala 2D array and I'm checking if it is safe, I am checking if it is land, if it is not visited, But instead of calling DFS, what will I do? I will add it to the queue. And how will I add it to the queue? I will create a new pair of what? Of 𝐶𝐞𝐈 and 𝐶𝐞𝐽. And this is what I'm going to add to the queue. Now, while adding to the queue, what else do I need to do? I need to mark this 𝐶𝐞𝐈, 𝐶𝐞𝐽 as visited. So 𝐶𝐞𝐈, 𝐶𝐞𝐽 is now visited. And that's it. We are actually done with the code. Let's try running it and see. So this works. Let's submit it and see. So yes, we have passed all the test cases in both BFS and DFS, and I wrote the code in both C++ and Java. And if you think I deserve your appreciation, if you think more people deserve to learn with me, and if I deserve to reach more people, please do consider sharing it with your friends. Please do help me reach more people. You have no idea how much it would mean to me. I'm working really, really hard. I'm trying to provide a lot of free content. It takes a lot of effort, but I am sure it is helpful for you. Please do let me know in the comments. At least comment that you have understood. At least let me know that you are writing the code and you're practicing it yourself. And see you next time. Be regular.